Welcome, everyone. My name is Emad Alashi. I work for a company called Insight. And today we are going to talk about the publish and subscribe component in Dapr. I'll try to make this talk as interactive as possible. So if you have any questions during the talk, feel free to raise your hand. If I know the answer, I'll answer you. If I don't know the answer, I'll act as if I didn't understand the words. So. All right, so before we talk about this, it's a good idea to put my dongle in 1 second to do what exactly? To be able to play with the mouse here. We had some issues before you just joined in. The screen was flickering and the HDMI did not allow us to do this the easy way, so we are doing it the hard way. Let me see if this works now. And I'm going to plug this in. See if this works. Beautiful. All right, so before we talk about the pub and sub component in Dapr, let's talk about Dapr itself. What Dapr is really? Dapr is a runtime that helps creating resilient, event-driven, stateful, and stateless microservices. You will not see the word microservices in the documentation probably. They are trying to make it work for any application really, but mainly it's for microservices. If you have a lot of applications and services that talk to each other. Dapr is it's started by Microsoft. It was created by Microsoft and still maintained by Microsoft. However, it's donated to the Cloud Native Computing Foundation. So this gives you an understanding who is doing the governance really, who's really owning. I should be careful of saying the word owning, but you can understand that this open source project is with the Cloud Native Computing Foundation, and you get all the benefits of having it being supported by such an organization. All right, how does Dapr really work? This is important for us to understand in order to understand the pub subcomponent. I'm gonna use my laser. If it works, if anyone has issues with seeing my laser, tell me. I can use my computer to point to stuff. So raise your hands. I'm gonna keep an eye. Every hexagon here we have is an application or represents a service that you're running, microservice, an application, web application. If you opt in to use Dapr, you will have a Dapr sitting next to your application. So if you have a web application and you run it in your local host, you also have a Dapr process that is running next to your web application. And I'm saying web application. I'm choosing this word because Dapr can be run in Kubernetes as a sidecar in the same pod as a container, but it also can run on a normal machine, VM. If your applications, if you opt in for microservices, but you did not opt in for Kubernetes, because you can do microservices without Kubernetes, maybe it's going to be hard, but you can. You still can get the benefit of running Dapr on virtual machine next to your application. So it's going to run next to your application, and they will talk to each other. Your application and Dapr will talk to each other through HTTP or gRPC. That's it. There's no hard dependency of your application on Dapr other than having this protocol talking to each other. But once you do this with the route configuration, you get benefits, things like state management. So for example, if your application needs to store key value pairs, the typical example these days is Redis. If you use Redis as a key value store for your application, once you have Dapr next to your application, you can use Dapr to maintain this state management. The default storage for Dapr is Redis. This is that comes with it. However, the people or the developers who created Dapr also created an abstraction layer so that you can opt in for different stores, the ones that you prefer. You can use Azure Cosmos DB, you can use Dynamo DB. But the default one is Redis that comes with it. And you don't have to install anything else. Once you install Dapr on your VM and you run Dapr, you already have that state management. We also have service invocation. So if you like any application, once you want application running, you probably want to communicate with the outer world through your application, make HTTP calls. If you do it through Dapr, you get service invocation, and it will act as a proxy. It's not exactly like we can't claim it's a proxy, but you channel your request through Dapr, and Dapr will do these requests on your behalf. What are the benefits? It can encrypt the channel for you, the request. It can encrypt it. Or if you have services and you want to have mutual TLS between them, you do this through Dapr. You don't have to do it yourself. You also get things like retries. If you send one HTTP request and Dapr will do this on your behalf, it's going to keep retrying until it succeeds and return the response for you. It can do circuit breakers and of the like. We also have secret management. Secret management is exactly, or not exactly, it's very similar to state management. That's the same idea. You can keep your secret in your secret store on your machine, or you can also use the abstraction that is built in Dapr to connect to things like HashiCorp Vault or the Azure Key Vault. We also have the input binding and the output binding. This is a little bit not too complex, but if you dealt with Azure Functions and you have the concept of executing your code based on events happening outside, it's very similar. And last is the publish and subscribe component, and which is the topic that we're going to talk about today. It also happens outside of your process, next to you in Dapr, and it will maintain, or it will handle everything that is related to subscribing to message brokers like RabbitMQ or Redis streams and the like. So this is how, in general, Dapr works. So with these common features, collectively, it becomes valuable to, as a runtime, to support your applications or architecture for microservices world. All right, so let's focus on the pub/sub part of things. However, before we talk about pub/sub in Dapr, we can focus on, or just go through how we do pub/sub traditionally, because it's going to help us to understand the value of Dapr. In the typical way, or the standard setup of our applications, normally we have application. This is our application. We have a business. I'm afraid to say the word layer because I'm too old for this, but it's the business logic. You have it in your application on one side, and then you have a lot of plumbing code that you write in order for you to communicate with the message broker, RabbitMQ in this example. You want to open the channel. You want to create the exchange. You want to create the event handler for when the event is received or the message is received, your code is executed. You want to close the connection, open the connection, all these plumbing things that you have to write in your code. Some teams go one step further, and they build an abstraction layer over this plumbing code. This gives them the liberty of choosing their own message broker to talk to. And I can hear some voices that might happen in your head and says, "Oh, are we doing repository again? The repository button? No one wants to change the database once they create it." However, with message brokers, it gives you the benefit of having message brokers, different message brokers for different scenarios. For example, if your application, your server at runtime in your production connects to Azure Service Bus, this is awesome, but once you want to develop on your local machine, you don't want to have another service bus, Azure Service Bus running on the cloud for you to run and test things. So what you'd like to have maybe RabbitMQ running on your local machine, light version that can help you code for that. With this abstraction, you get the chance to do this. And of course, if you want to change your message broker in the future. But this is very common now to make it easy for developers. All right, pub/sub with Dapper. What does Dapper do? What does Dapper bring to the table to make this easier? This is a general slide. So your application is living in a different process. This is the same virtual machine or the pod in Kubernetes. Your application is running on a different process, and Dapper is entirely on a different process. With the right configuration, Dapper will communicate with your business logic through your HTTP or gRPC, and all the plumbing code that is required to communicate to the message broker is handled by Dapper itself. All the things that I just mentioned about opening the channel, listening to the events. So once a message is sent on RabbitMQ, for example, Dapper will pick it up and then will send it as an HTTP message or gRPC message to your application. So the only thing that you need to care about in your application is creating a couple of endpoints, HTTP endpoints or gRPC, and the logic that you need to deal with that message. That's all. If we also go one step deeper in order to understand how this really works, the minute you start up your application with Dapper, both processes will start up, but at the beginning, your application will start up before Dapper. It's expected from Dapper, let's focus on the subscriber now. It's expected that once you create your application that you have such an endpoint. Localhost, your app port, and then I keep my pointer is disappearing. Is it disappearing? It is disappearing, actually. This is so weird. OK, I'm going to use my pointer. I don't know if this is going to work. All right. Control A. All right. So you can see here that we have this hard-coded. It's harder than I thought with 3 fingers, actually. Let's see how this works again. You can see, there you go. This part is hard-coded in your application, or it's an endpoint that is expected to be living in your application. Why? Because Dapper will call it. The minute you start your server and your Dapper sidecar starts with your application, Dapper will call this endpoint. And it will be expecting something like this. You can see here that we have an array of JSON objects. And this array of JSON objects, these objects are configurations that will tell Dapper how to subscribe to the message broker. So the first one, you can see that we have the component name, the pub/sub name. This is to differentiate between the different pub/sub components in your ecosystem. We have the topic. This means that for this configuration, I want to listen to topic A in the message broker. And for any message that is sent to the topic A, I want it to be routed to the route A. This is an HTTP endpoint in your application. And this is it. You are expected, of course, to have such an HTTP endpoint. And the same configuration for topic B and route B. So once your application starts up and Dapper sidecar starts up, and it invokes this HTTP endpoint, it takes the configuration, it stores it inside, and then it subscribes to the message broker based on this configuration. The configuration in the yellow box up there, it has the configuration, how it connects to the message broker, the connection, the username and password for that message broker. On the publisher side, we have also Dapper created, started with us, with the publisher, but it's going to be a simpler story. The publisher just needs to send a message, HTTP message, on this endpoint. Your application port, or the Dapper port, the publish word, it's hard-coded, it's very it's concrete. And then the publish pub/sub name, this is the name of the component there, pub/sub, and the topic that you are sending to, topic A, topic B. This is the where you want the message to be on the queue. The publisher will send the JSON to that HTTP endpoint, to that topic, and then Dapper will make sure that this message is posted to the message broker. Once it's posted to the message broker, the subscriber will be listening to that message, that topic, will find the message, bring it down, and send it to your subscriber as an HTTP endpoint. All of this plumbing is taken care of for you. Dapper do it for you. All what you need to do as a publisher and subscriber is to surface these endpoints and expect that you are going to receive a JSON message as a message. All right, now let's dig into the meaty stuff. Let's find a demo. I really wanted maybe zoom in. In my old days, I used to write code live in the sessions, but I grew old. I'm falling back to snippets. All right, let's go to Visual Studio Code and explore our solution. So this, I opted in. Let me, I want to end this presentation because I want to mirror rather than, and is it mirroring? Yeah, beautiful. I can see now here now. All right. This example is actually an example from the Dapper Quick Starts. I'm going to provide you a link at the end of the talk. You can go there and use this quick start. However, I made some changes to make this more make sense, like orders and shipping containers and stuff like this, rather than route A, route B. So if you found these differences in the quick start, you understand what's going on. So in the PubSub folder, you have the node subscriber. If you can see it here, this is a Node.js application that we are going to use as the subscriber, to demonstrate the subscriber. And we also have here at the bottom, we have a React form. The React form is really the publisher. I don't know why the team called it React form. I think it's because the interface is just React form that you use to publish the messages. However, you can see that there is a server down there that will act as the publisher. So you send the message from the React form to the server, and the server will send it to Dapper. Now let's have a look at this interesting file. I'm going to hide this. If you look at this file, it's a YAML file of kind component, and the metadata name is called PubSub, and the type is PubSub Redis. This YAML file, you can see that it exists in the user profile folder under .dapper. This is where you put the configuration for Dapper so it can connect to the message broker correctly. Of course, you don't have to be stuck in the Dapper folder. You can also, once you run Dapper itself, you can say, I want to use a different configuration file, and you can point to that configuration file. However, to make your life easier, the developers of Dapper just assume that you're going to have all your configurations in the .dapper folder. You can look at the details of the file as well, and you'll see that we have the name of the host of the Redis message broker, and also we have the Redis password. This is to allow Dapper to connect to Redis. Now let's go back and check the publisher. In the publisher, all what we have is localhost Dapper port version 1. We have the port that we are going to run the application on. And in order for us to publish the message, we just push or make a request, a post request to this URL, the Dapper URL, publish, the PubSub name, the component name, and then the topic we are submitting to. all what you can see is there's a post to that JSON. So if I go back now to the app.js, this is the subscriber. Let's have a look at the subscriber. The subscriber, on the other hand, just provides an endpoint that's called subscribe. And this is the subscribe endpoint that we talked about earlier. We are expected to return the configurations or the intentions of our application to which topic we want to subscribe to and to which route we are delivering these messages. So, for example, if we have a topic called orders, if we have a topic that's called orders here, we want it to be routed to the process orders route. So if I scroll down here, you can see that I have this endpoint available for me. And all what I'm going to do is to console log the process orders on my console. All right, let's now run the applications. The way to do this, and let's zoom in. We have the React form, and we have this command. Can everybody see clearly the command? All right, beautiful. We have Dapr run. Application ID is the node subscriber. This is very important because increase the font. I think this is asking me. Oh, here you go. Better? Awesome. All right. You can see here that we have Dapr run. The app ID is the node subscriber because every application you run with Dapr, it has an ID to distinguish between the different applications in your microservices or the different services. This is going to be very important for us later once we want to do competing consumers. And the app port we are running our application on, and then this is the command that runs your application, the Node.js. If we do this now, if we run this command, we want to see, or we are hoping that our application will work. Here you go. Oh, what's happening? Oh, I know now. Let's resume Docker. And then, because you need to have Docker running. All right, this is not going as planned. I'd like to receive any error. Nothing? Okay. How about expanding? And Dapr run app ID one last time. Maybe Docker is going to run eventually. Okay. Absolutely nothing. How about we run this one? See what the problem is. Run node subscriber. Ah, I know now. That was so silly of me. Because in the first window, this is the React form. We want to run the React form. There you go. Is it refusing as well? Okay. I'm not sure what's happening there. Let me cancel. I'm going to cancel both. I will exit these ones and maybe reset the zoom. Maybe it's the zoom. I will run the node subscriber. Docker is running. I'm going to remove the do not disturb. Maybe it's doing something else. Oh, my goodness. This is very interesting. All right. Let me do one last thing before we fall back to other stuff. Because this is really the essence of the talk. I have no idea why it's not working. It was just working a minute ago. Let's restart Docker. Restart. Could it be there's no internet? Let's connect to my dongle. I'm just trying to troubleshoot everything I can for this one. It's restarting. Well, without failures in demos, you can call it a demo. I'm hoping that things work fine. If it doesn't, then we will have to go back to the theory part of things. I'm sorry if this is disappointing. And I'll be in this conference for the remainder of the conference. So if you really want to see this working, and if it doesn't work now, you can talk me and you again and see how things go. All right, so let's try again. Maybe cancel the whole thing. PW. And then new terminal. And we say NVM, use node, just to make sure that we are fine. And then we run Dapr, the React form. There you go. Woof, finally. I think it was the zoom for some reason. I zoomed in again. All right. Sorry for the disruption. So let's look at the log. There's a lot of log coming from here. You can see that all of this log is from Dapper. It gives you a lot of built-in features to support metrics. When you send requests through the MTLS and the service connection, it does this for you. It currently is disabled. You can see that the app ID is React form, and you can see that it has loaded the component called PubSub on Redis, and it's ready to listen to the topic that's called orders. We can see, where is it? Internal GSP, metrics, scope, here you go. Okay? Now, this is the form. Let's do another one for the node subscriber. And before do that, let's send a message and the subscriber. This is the agenda. Oh, this is not the thing that you should see. All right. And what we do is that we will go here and see if we have a message here. Of course, it's not working, so we have to go back to the, all right. Where's our terminal again? Bring it to desktop 4. Or desktop 3, was it? And then what we wanted to do is to open another terminal, this on another tab, and we want to run the commander. This is a Docker container to have the UI of the Redis running. It's just the UI, so if I refresh this, it's just the UI. It's connecting to my server, if it works nicely. All right, it's good. Today is not my best day for this. Why is it not running? This 3679. Ready to accept connections in my configuration. It's 3679. All right. Let's see what we can do here. I'm going to change something. I'm going to change from my snippets. I'm going to run, rather than run Redis, I'm going to run RabbitMQ and see if this works. I'm going to save, go back to our applications, and then run this again. And see if RabbitMQ, let's also create RabbitMQ. There you go. So this runs the RabbitMQ message broker. So if we go here and reload, wow. There you go. All right, so here we can go to the exchanges. You can see there's nothing. All right, so what I did here is that for some reason the Redis is not connecting properly to my Redis server. So what I switched my configuration to, rather than using Redis as a message broker, I switched to RabbitMQ on the hope that it's going to work. So my RabbitMQ is working now. Now, if I post a message on my React form, let's see if it's working. It's working. So if I say, if I'm going to send a message to, this is an embarrassing demo, submit. Let's see if we have a message here. Queues, exchanges. Might take some time. No. Channels. All right. If we run the subscriber, all right, so you can see here, okay, nice. Well, it's not too nice. We didn't receive any messages here. Let's see if we are going to send another message. React form, please work. I can't be more imaginative than this. Here you go, finally. This is the not subscriber. Thanks so much. It should be much better than this, really. So you can see that in the subscriber that we have received a message down there that says process orders and all the information. You can see here in the data section we have the message type orders and the message please work. Now, the thing I wanted to bring your attention to is that this is not what we sent. What we sent was only this, message type, orders, message, please work. All of this content in the message itself is actually a wrapper. Like the object was, or the message was wrapped by something called cloud event. Cloud event is the format that the industry has standardized against to wrap messages between microservices and event-driven systems. The reason why they have standardized on this because you can have a lot of information like the trace ID and the type of the topic. All of these things are part of the expectations of the standard of the format, and microservices can assume that all this information is going to be there. Actually, I think the failure of the demo was good to show that I only needed to change the configurations to switch between message broker that is from Redis to RabbitMQ. This tells you the power that you can get with Dapr. I didn't touch the code. You see, like the Node.js, I did not change. It's exactly the same HTTP endpoint. All right, let's have a look at something. If we don't want to wrap our application in cloud event, let's say if we have legacy application, we can copy this line and go back to our server. And instead of this line, I'm going to use this line. I'm going to comment. Format document. Oh, for God's sake. All right. So the only difference between these two lines is the last part, is metadata raw play load equals true. So I don't want to wrap my event or message with cloud event format. I'm going to save this one and go again to my React application. I'm going to cancel it and run it again. And then I'll send another message. This is not a wrapped message. Submit. Did it work? And you can see at the bottom here in the subscriber, I'm going to switch to the subscriber. You can see here at the bottom, I don't know, I'm afraid to zoom in after the last experience, but you can see at the bottom that there's a message from the process orders, a message type orders, the message is not wrapped a message. All the cloud event format is not there. All right, let's look at something also interesting. Let's say that you have a big application and it has a lot of endpoints and a lot of message types. So you want to route the message to different routes rather than one big endpoint that receives all the messages, and you have to do if clauses in your business logic. You don't want to do this. Let's give a more concrete example. This is called the routing part of Dapr. If we go to our app and we look here, you can see that this is the route we have. Imagine that in orders, in the orders endpoint, the process orders, we want to have a lot of logic around specific subtypes within the topic that's called order. If I go back to my snippet and I'll borrow these lines and replace it with this. All right, so let's examine the code. This is exactly the same configuration that we had before, except instead of having one root value, the process invoices, we have roots and we have an array of rules. So when a message comes to Dapr will evaluate these rules, and based on these rules, will direct to the different paths. So we have here, for example, in my example, I have the rule that says if the event.data.message equals computer, I want it to be routed to the process computer's orders. And I can go crazy, not too crazy, but there's this expression I can have multiple ways and can interrogate many attributes in my event to route to the right path. So I'm going to save this one and go back to my subscriber and run again. Now, if we go to our app and say orders and say this is a normal order, submit. We go back. You can see that this is a normal order. Oh, error handling message from topic orders, no such key data. App ID, not subscriber, instance, scope, Dapr, contributor. Error handling message from topic orders, no such key. Okay, I'm not sure what this is. Yes, good on you. All right, let's do this. My God, you're an awesome audience. Let's do this. Let's go this. In the React form, Control Z, and save. And then what we'll do is Control C here, go back to my RabbitMQ. It's already, let's refresh. I want to delete this one because I don't want to have issues. Delete queue or no. Get messages, and then I don't want to delete the queue. I know. Act mode. Get messages. I hope so. Okay. And then we run this form again, and we run this again. All right, it's running. Test. And we have process orders. This is the subscriber. You can see we have tests. But if we go back and we say computer, submit, you will see that it says process computer orders. So we are routing the right message based on the content type of the message. All right, so this is for routing. Did I want to show anything else? I think with these three, you can see that you can see the value that Dapper provides or brings forward to your application, because you are going to not deal with a lot of the plumbing. It's all HTTP and rules. The one thing I wanted to show you as well is that for the expressions, for the rules, it's based on the common expression language. This is where you can find a lot of information about how to write these rules, because it might be like, if it's not normal code. For example, you have to has string or has value. There's certain ways you can write these rules. All right, let's go back to the presentation and do some final thoughts around Dapper PubSub. One of the things that we did not cover, and I'm very happy to answer after the talk, is about the time to live and the did letter queues. In Dapper, you can specify in the configurations the time to live for the message. If the message broker supports did letter or the time to live configurations, Dapper will just pass through this configuration to the message broker, and it will deal with it. If it doesn't, Dapper will do this for you. It will monitor the time to live of the message in the queue, and then will deal with it and move it to the dead letter queue if necessary. Another thing to think about is that the patterns of consumption. So we know that if you want to have one publisher and many subscribers who are doing different things. So the same message goes to these different subscribers. These subscribers should have different app IDs. This is going to fan it. However, if you have many consumers that are competing on the message, for example, this is a typical scenario for if you want to have a concert and there's a lot of queues and you want to increase the scalability of the processors, so you increase the processors so they can process messages faster. These are the competing consumers. All these consumers should have the same app ID. So it's used as many instances for the same application. One of the things that we need to talk about is the scoping. In the pub/sub component, you can limit what applications subscribe to, what topics they can subscribe to, what topics they can publish to. This will also allow you to have more constraints that if you're an architect and you did this pub/sub component, you're not worried about if the developers listen to the wrong topic or not. Finally, challenges. Of course, life is not too rosy in every technology. The first problem is that if we are introducing abstraction, and abstraction means you are losing control. You are not, you don't have all the luxury that you have in writing the code yourself. Of course, Microsoft or the team has done a very good job in trying to still give you some space in configuring things differently for the different type of message brokers. As you have seen, the different YAML file between Redis was very short, and the YAML file for RabbitMQ was so big. They are trying their best to give you this flexibility. However, it's still an abstraction, and you lose some control. The other thing with this abstraction is that you also lose, you have to go through troubleshooting. For example, just like we saw a minute ago, I was stuck. I couldn't see any logs. I know that I was on the spot. However, if I had owned the code 100%, I would have more space to navigate. However, these two things are normal in any technology. If you are introducing a new good package that does something in your code, you are going through this. You are giving away some control, and you are giving away some troubleshooting, or you're expected to do some troubleshooting in your things. This is all what I wanted to talk about today in Dapr pub/sub. I have this code and the presentation on this URL. It's not too much different from the quick start, like I said, but I did some changes so you can see the roots. And that's it for me. If you have any questions, I'll be very happy to answer. Thanks. An apology for the drama of the demo. Any questions? Can you strongly type routes rather than having magic string? You can. I'm not sure if you can do this. However, in the let me cancel the presentation here, and we go back to the code. You can see here that in the rule, it's from my understanding is that you have to follow the message format or this expression, the common expression language, and I don't see any way that you can do it strongly typed. Maybe if you tweak it yourself, you can put constants or the like, but I think you are bound to the matching rules of the expression. So probably not. Maybe if you just tweak it yourself.
So like as an example, the second one you got there, so not with the match, like where you just got the route as process invoices.
Oh yeah. This is you can totally have different endpoints for the different topics, and the different topics are already segregated for you on the routes. But for the same topic, if you want to have multiple routes for the same topic, based on details like the body of the message or anything of the like, then this is where routing becomes handy. All right, I think this is it. If you have any questions, I'll be hanging till the end of the conference on Friday. Thank you so much for attending, and thank you for your patience, and see you around.